Okay, today we're going to be looking at chemical equations. Now remember, we have done some things where you have abbreviations for elements called symbols, we have abbreviations for compounds called formulas, and now we're going to be looking at abbreviations for chemical reactions, which we call chemical equations. These are the different parts of the chemical equation. Whatever you begin with or whatever materials are undergoing the chemical change, these are called the reactants, and they appear on the left side of the equation. Your materials that are formed as a result of this chemical change are called your products, and these will appear on the right side of the equation. And you may only have one product, you may only have one reactant. It kind of just depends on the type of reaction, which we'll talk a little bit about later. And then you have an arrow that separates the reactants from the products that shows the direction of the reaction. It would be read as yields. So if you look at this particular equation that we have drawn here, these two substances are going to be reactants because they're on the left side. They're undergoing the chemical change. This is yields, and it shows that the reaction is going to the right or toward the products. And then, of course, this would be my one product. So if I was reading this to you, it would be sodium reacts with chlorine to produce or yield sodium chloride. Now, sometimes you will see arrows going both directions, like in this particular example down here at the bottom. This is a reaction that is reversible. And some of the reactions that you do are reversible. A lot of these that take place in the body are reversible because we have to keep a balance, or what they call a homeostatic situation, or homeostasis in the body. So in this particular case, if you take in a lot of carbon dioxide, or if you're holding a lot of carbon dioxide, then it's going to be converted into this compound and vice versa. So you can store more carbon dioxide in this form, and it can travel in the blood this way. Or if you want to get rid of extra carbon dioxide in the blood as you exhale, for example, then it would be reversing this direction, and then, of course, this would be a product that could be exhaled. The one thing you're going to be looking at on these are balancing equations. This is based on the law of conservation of mass that states that mass can neither be created nor destroyed, but it can be changed in form. So whatever you start with, basically, you have to end with on the opposite side. So if you have a certain amount of one substance in the reaction, that's a reactant, then you should have that same quantity in the products. So if we're looking, for example, at this one, I went the wrong direction. Here's some examples of balancing equations. If you're looking here at this particular problem, we'll come back and go to the slide prior to that in just a second. You see that you have two nitrogens here, two hydrogens here, but on the product side we only have one nitrogen and three hydrogens. So our goal is to make sure that the number of nitrogens on this side of the arrow balances with this side, and the same with the hydrogens on both sides. In order to do that, we put numbers in these blanks. These numbers are what are called coefficients. So I'm going to go back to one slide. The coefficients are referred to as the formula unit also. They do represent mole values. So when you're doing these, in order to balance an equation, you're going to put numbers in front to indicate quantities of each of the substances in this reaction, and you want them to equal each other on both sides. So what I always do is draw a line between the two substances, between the reactants and the products, and then below each of the substances I put what I have. So I have like one sodium here, I have two chlorines here, and then on this side I have one sodium and one chlorine. Now the reason I do it this way is because I can put something in this blank and not any other blank, so I can change this quantity without having to affect any of the other quantities. So it's not really like math where if you do this to this side, you got to do it to that side. This is completely different. So now what we want to do is compare the two sides. So I have one sodium on this side, one sodium on this side, so it's balanced at the moment. I have two chlorines here, one chlorine here. So in order to balance this, I need to multiply this by 2. Since this chlorine and this sodium are linked together as a compound, the sodium also gets multiplied by 2. So that means that I'm going to have 2 sodiums now on my product side, 2 chlorines on my product side. That balances out my 2 chlorines on my reactant side, but now I've got to come back and fix this side so that I have 2 sodiums over here as well. So I'm going to multiply this one by 2. Whatever I multiplied by becomes the coefficient that would go up here. And on top of that, you're going to put a 1 wherever you don't have to do any additional multiplying. So let's look at a couple more examples. Let's look at the number 2 that's on our balancing here. So the first thing you want to do is to draw a line to separate your reactants from your products. In this case, we only have 1 reactant. We have 2 products. And then below each substance, you want to write down what you have. So in this one, I have 1 potassium, I have 1 chlorine, I have 3 oxygens. I always put a little curly Q on my O's so I don't get it mixed up with a 0. On this side, in this substance, I have 1 potassium and 1 chlorine. And in this substance, I have 2 oxygens. So now I want to compare the 2 sides. So my potassiums are balanced, my chlorines are balanced. I have 3 oxygens here, but only 2 oxygens here. So since I can't multiply 2 by any whole number to get 3, I'm going to have to look for the lowest common multiple, which would be 6. So I need to come over here and multiply this one by 3, so that's going to be 6 oxygens, meaning I'm going to have to come over here and multiply this one by 2, so I can also get 6 oxygens. But we're not finished because these 2 substances here, the potassium and the chlorine, are also linked to the oxygen because it's part of this compound, so they also get multiplied by the 2. Since now that I multiplied these by 2, I'm going to have to come over here, and I would also have to multiply this by 2. Again, both of these are in the same compound, so they both get multiplied by 2. And now that's going to balance out this equation. So I have 2 potassiums, 2 chlorines, 6 oxygens. I have it balanced. So on this one, I multiplied this by 2. Here I multiplied this by 2. And here I multiplied this by 3. So these would be the coefficients for this balanced equation. You can always go back and check. So for example, I can say 2 times 1 gives me 2 potassiums. 2 times 1 gives me 2 potassiums. 2 times 1 gives me 2 chlorines. 2 times 1 gives me 2 chlorines. 2 times 3 gives me 6 oxygens. 3 times 2 gives me 6 oxygens. So that's one way you can go back and check and see if your work is correct. So let's look at another one. Let's look at this one in the middle, number 5. So on this one, you can see that you have a polyatomic ion here, but you have the same polyatomic ion here. So to speed up the process of balancing, since you don't have nitrogen or oxygen anywhere else except in that polyatomic ion, you can keep that together as a unit. So I'll go ahead and show you what I mean. So here I have 1 silver, and I'm going to keep this together as a unit, so I have 1 nitrate ion. Here I have 1 magnesium and 2 chlorines. Over here I have 1 silver, 1 chlorine, and this one I have 1 magnesium and 2 of the nitrates. So now we want to make sure everything is balanced. So I've got 1 silver on this side, 1 silver on this side, so that's balanced for the moment. 1 nitrate, 2 nitrates. So that means I need to come over here and multiply this side by 2. Since these are linked together as a compound, they also get multiplied by 2. So I'd have 2 silvers now and 2 nitrates. So I can go back and fix the silver if I want to. So I have 2 here, 1 here. So I'm going to have to multiply this one by 2, which also multiplies the chlorine by 2. I have 1 magnesium, 2 chlorines, 2 chlorines. Now I have it balanced. So on this one, I multiplied the first substance by 2. This one I didn't multiply by anything, so we'll put a 1. This one we multiplied by 2, and this one a 1. So as long as all of the elements that are in a polyatomic ion are in the polyatomic ion on the other side and not somewhere else, you can keep it together as a unit. So if you look at number 6, we can do the same thing. So we have 1 aluminum, 3 bromine, 2 potassium, 1 sulfate. Over here I have 1 potassium, 1 bromine, 2 aluminum, 3 sulfate. So again, we're going to go back and balance. So I have 1 aluminum here, 2 aluminums here, so I'm going to multiply this one by 2. And it doesn't matter where you start, just as long as everything gets balanced in the end. So that's going to give us 6 bromines. I have 6 bromine here, but 1, so I'm going to multiply this one by 6, which also multiplies the potassium by 6. I have 2 potassium, 6 potassium, so I need to come over here and multiply this one by 3. I don't run out of room there. And I have 3 sulfates, 3 sulfates. So now I've got 2 aluminums on both sides, 6 bromines on both sides, 6 potassium on both sides, 3 sulfates on both sides. I'm balanced, so I multiplied this one by 2. I multiplied this one by 3. I multiplied this one by 6. And I didn't have to multiply this one by anything, so we put a 1. Now I want to look at one other type of balancing. So there's a lot of practice problems on here that you can try, but I'm going to look at one like this. Now if you'll look at this particular set, you can see that all of them start off with a compound that has carbon in it. These, remember, are organic compounds. And everything else is the same. So they're all reacted with oxygen, and the products are always the same, carbon dioxide and water. This is a special kind of reaction that's called an oxidation reaction. Excuse me, it's called a combustion reaction. I messed up there. So this is a combustion reaction. And we'll be looking at these in a little bit, but combustion reactions typically are going to have some kind of an organic compound reacting with oxygen, and your products are going to be carbon dioxide and water. Now again, it doesn't matter what order you put the carbon dioxide and water on, as long as they're on the right side of the arrow. So if you put water first, then carbon dioxide, that would be just fine. Now there's a special way to balance these that just makes it a little easier in my opinion. So we're going to look at the first one. Now this one's pretty simple, and it's pretty obvious. You can kind of balance this one probably in your head, but we'll go ahead and do the same process as we did earlier. So we got 1 carbon, 4 hydrogens, 2 oxygens here, 1 carbon, 2 oxygens, 2 hydrogens, 1 oxygen. Now if you'll notice that no matter what I put here, if I multiply it by 2, that's going to give me an even number. But on this side, I have oxygen split up, so if I need to make sure this side is equal to this side, I got to add these together, so I'm going to have 3, which means I'm going to have an odd number of oxygens on this side. So the first thing that I always do when I'm doing a combustion reaction is I multiply water by 2. What that's going to do is going to give me an even number of oxygens on both sides. So that's the first thing I'm going to do. And then if you'll follow these other steps on the order of balancing, it just makes it so much easier. So if you balance your hydrogen first, then balance your carbon, and then finally balance your oxygen. If you'll do these 4 steps every time when you have a combustion reaction, it just makes it easier, and you don't have to go back and forth between substances like you might if you were doing it just kind of in the order that we had done earlier. So we're going to go ahead and balance our hydrogens now. So we got 4 over here. We have 4 over here, so it's already balanced, so that made that easy. We have 1 carbon, that's already balanced, so that was easy. And then we need to add these 2 together. So on this side I have a total of 4 oxygens. So I need to come over here and multiply this by 2 to give me 4 oxygens. So here I didn't multiply by anything, here by 2, didn't multiply by anything here, and here by 2. Now that one was pretty easy. But when the numbers on the carbons get bigger, so for example, when we get to this one, then these numbers are going to typically get bigger. And the bigger these numbers get, the bigger these numbers get. They can actually end up being 2-digit numbers sometimes. So I'm going to do number 8 with you, and then I want you to try number 9 on your own. And then we'll look at that one another time. All right, so let's go ahead and do this one real quick. So we have 3 carbons, 8 hydrogens, 2 oxygens, 1 carbon, 2 oxygens, 2 hydrogens, 1 oxygen. So again, following our steps, the first thing we're going to do is multiply our water by 2. So that's going to give us 4 hydrogens and 2 oxygens. Then we want to do our balancing of our hydrogens. So we got 4 hydrogens here, 8 hydrogens here. So it needs me to multiply this one again by 2 to make it 8 hydrogens. Again by 2, we'll make it 4 oxygens. So our hydrogens are balanced now. The next thing we want to do is balance our carbons. So we have 3 carbons on this side, 1 carbon here. So that means I need to multiply this one by 3. That's going to give me 3 carbons then on both sides, 8 hydrogen on both sides. So now I need to add up all my oxygen. So I have 6 on this one and 4 here. So that's going to give me a total of 10 oxygen. So you can see that it kind of helps have that little curly Q on the O, so you know that you don't have 100 oxygen. And we need to come over here. Since we have 2 of these, we'll multiply this by 5. That's going to give us our 10 oxygens. So we didn't multiply this one by anything, so that's a 1. Multiply this one by 5, this one by 3, and this one, we multiplied by 2 first and then by 2, so we need to multiply those together to get our coefficient of 4. Again, you can go back and check. So I have 1 times 3 gives me 3 carbons, 3 times 1 gives me 3 carbons, 1 times 8 gives me 8 hydrogens, 4 times 2 gives me 8 hydrogens, 5 times 2 gives me 10 oxygens, 3 times 2 is 6 oxygens, plus 4 times 1 is 4, so 6 plus 4 gives me 10 oxygens. So try this number 9 for yourself, and then on the next video I will go through and work this one with you if you have questions.